this is the plan for today. We are going to start talking about thermodynamics and thermodynamical laws. So there's basically 4 laws, 0, 1, 2, 3. And so we will, in the first 7 weeks of the semester, talk about those 4 laws. We are also going to talk about thermal expansion and pressure. So are we ready? Remember we started talking about temperature last time? And we said, what is temperature is how we feel about it. So now let's try to put how we feel about it into context of what is temperature, as we call them in physics. So I'm going to give you a couple of definitions of what temperature is. So the first definition I'm going to give you is what I'm going to call the operational definition. And that is what we were talking about. Temperature is what you measure with a thermometer. So, what do you have to do? You take say a mercury thermometer. You put it into, say, soup. Something else. A room, soup, whatever you want to measure. Into a room, soup, or whatever you're measuring. Then what do you have to do? Wait a bit. And then look at the scale. It will tell you how hot or cold that thing is. So an operational definition of what temperature is how you measure it. Now, when I said wait a bit, what did we call that in physics?
Reaching
relaxation time?
Relaxation time.
Yes. So we called this relaxation time. Now, what is happening during relaxation time? The 2 things are reaching the same temperature, right? When the 2 things reach the same temperature, we call it thermal equilibrium. Okay, so look at the scale. So relaxation time leads to thermal equilibrium. And what is thermal equilibrium? Is when the 2 things reach the same temperature. So that leads me to define temperature in another way. So number 2. Temperature can also be defined as when you put 2 objects in contact with one another and wait long enough, putting that word in inverted commas, they tend to reduce to the same temperature. And that is a very common observation, right? You take your coffee, you put cold milk in it. What happens? The milk
Heats up,
and coffee
cools down.
until they are both at the same. So they reach thermal equilibrium. So this leads me to define what is thermal equilibrium. So the proper definition of thermal equilibrium is when two objects are in contact long enough, they are called to be in thermal equilibrium. When they reach thermal equilibrium, will the temperature change? So how do I write that in physics? Delta T equals 0. Now here's a fun fact. What does this word mean?
And an open system.
They are in an open system. But what kind of a contact will that need to be? So think about it. Milk and coffee, they are in physical contact with each other. Sun and the earth. The sun is radiating and we are receiving. Make sense? So in contact could be when you're physically in contact with something, or when you are just receiving from far away. Okay, so contact could be physical or it could be at a distance. And when it is physical, that means they are touching each other. When it is, so this could be touching, and this could be radiating at a distance. So now, this leads me into my third definition of temperature. Which is temperature is the measure. Temperature is the measure of the tendency of an object to spontaneously give up energy to its surroundings. When the two objects are in thermal contact with each other. So this definition connects temperature to energy. I think, Andy, you said that last time, right? And that is how chemistry developed. So higher temperature means higher kinetic energy of the molecules. Lower temperature means lower kinetic energy of the object. So which one loses more energy, or which one loses the energy? The object at higher temperature loses the energy, and the object at lower temperature gains the energy.